Hi, welcome to my ArcGIS tutorial on coordinate systems. I hope this tutorial will be useful for people who work with multiple data sources. Different companies or people work with different coordinate systems. We will learn why they do that and how to work with data with different coordinate systems. Let's see what we will cover in this tutorial. First, we will learn about the coordinate systems. We will learn about coordinate systems used for specifying locations on Earth. Then we will learn about geographic coordinate systems, projected coordinate systems, datum, etc. We will also learn about distortions and we will jump on the ArcGIS to create a coordinate system and resolve conflicts. A coordinate system is a system that uses one or more numbers or coordinates to uniquely determine the position of the points or other geometric elements on a manifold, such as Euclidean space. There are many coordinate systems. Some of them are Cartesian coordinate system, polar coordinate system, etc. We also have some coordinate systems for locating things on the surface of Earth. They are called geographic coordinate systems. The geographic coordinate system, or GCS in short term, is a spherical or ellipsoidal coordinate system for measuring and communicating positions directly on Earth as latitude and longitude. For example, Universal Transverse Mercator. Now let's talk about datum. Datum is used to determine the origin of a coordinate system. Projected coordinate system or PCS is created when we apply custom projection parameters to a geographic coordinate system. It is used to minimize the distortion of features. For example, BTM and BUTM. Let's learn about distortions. When we try to flatten a spherical surface, there must be some kind of distortions. It can distort the distance or direction or shape or area or some combination of them. Our goal is to minimize the distortions to deliver accurate representation of the real world. But we cannot do that for the whole world. That's why we try to use such a coordinate system that we will minimize the distortion for our area of interest. For this reason, there are so many projection systems. Every one of them has specific purpose and look into it. With this knowledge, let's create a projected coordinate system. For example, let's create a PCS based on UTM. We know that Bangladesh lies in UTM 45N and UTM 456N. We will change the projection parameters of UTM to get the whole Bangladesh into one UTM zone. Now let's hop into ArcMap to try to make a PCS. After opening a new project, let's open the properties window of our data frame and go to the coordinate system tab. We can see three folders here. We might have more, but we will have at least two, which are geographic coordinate systems folder and projected coordinate systems folder. There are hundreds, if not thousands, of coordinate systems in there. Let's focus on what we, the Bangladeshi people, use most. For geographic coordinate system, we mostly use Everest Bangladesh in Asia folder. For projected coordinate system, inside UTM and inside WGS 1984, we mostly use UTM zone 45 and 46N. Now, going that deep inside folders every time is cumbersome. So, we can add the important ones to favorite list if we need. I have these coordinate systems in my favorites folder. Let's learn how to create a projected coordinate system. Let's click this button and inside new and select projected coordinate system. It is the new window where we specify the parameters and settings for the new coordinate system. We set the name in the first field, then select the projection type. Now the rest of the things may seem a bit complicated. Let's learn about them. To make a PCS, we must know what a PCS needs. It needs a geographic coordinate system and some projection parameters. We know that our GCS is UTM, so let's select it. Lastly, we must put the projection parameters. Let's try to understand the variables. The central meridian is the center line of longitude for projection systems. We use it as the x-origin. False easting and northing are used for avoiding any negative easting coordinates. It is used for offsetting the origin. Scale factor is used to scale everything. Latitude of origin defines the origin of y coordinates. This parameter may not be located at the center of the projection. Now let's look at example value. We are currently looking at the values of projected coordinate system named BTM. It stands for Bangladesh Transverse Marketer. It is a modification of UTM to minimize distortion inside Bangladesh by keeping it in one UTM zone. It uses GCS Average Bangladesh as its geographic coordinate system and uses values shown in the image as projection parameters. Now let's see a problematic situation. Suppose we have a feature class with unknown coordinate system. We can see it in the properties window in source tab. If our data doesn't have the proper coordinate system defined, then it will not match with the other data and create errors in our work. So we will use a tool called define projection. This tool overrides the coordinate system information stored with a dataset. So let's apply it to our data. The tool is in data management toolbox, projections and transformations folder. Let's open it. Here we can read the whole help section if we want. Anyway, I am going to input our example data and then we can see that it has unknown coordinate system. Let's set it to BTM. As for my case, I know that it should be BTM. Let's click OK. Now, after execution, we can see in the properties window that our data has BTM as its coordinate system. Let's solve another issue. This time we have data with known coordinate system, but our working session has another coordinate system. Let's see what we can do to resolve the conflict of different coordinate systems. For this, there are two ways. First and easiest method is on the fly transformation. Let's check this out. Let's say we know that quad boundary layer has BTM as its coordinate system. Let's create a new data frame and set a different coordinate system. For example, UTM-45N. If we want to import the data with BTM coordinate system into our new data frame, it shows us a warning. We have a conflict because the feature class have different coordinate system than the data frame. It is giving us option to do some transformations so that we can use the data in our specified coordinate system without any error. Let's click on the button and we got a new window with some options. We will convert from GCS Average Bangladesh into WGS 1984. For that, we must specify a method. The method tells ArcMap how to do the transformation so the data will look correct. We can see that I already have transformation method for this situation. If I didn't have that, I would have to make a method by clicking new button and specifying some parameters. We can add a name to it and select transformation method as we need, then specify the important parameters. These parameters are available online. Anyway, I am going to cancel that as I already have one. We can see the summary of the parameters here. Let's click OK to accept the transformations. Now the layer is displayed in our coordinate system on the fly because we can see that the layer is still in its original coordinate system in its properties. Let's learn about another way of solving this issue. This time we will permanently set the coordinate system of the layer as our wish. Let's consider the previous situation and work from there. Let's now make a new data frame and set the coordinate system to UTM-45N. This is our target coordinate system. Let's open the project tool which is in the same folder as define projection tool. I am inputting the feature class, the target coordinate system. Finally, after setting the output parameters, if I click OK, it will write a new shapefile with the specified coordinate system. If we drag the output in our data frame, it won't give us warning because the coordinate systems of our data frame and feature class has matched. There are no conflicts. Let's see what happens if we don't apply any transformation. If we drag the layer with the different coordinate system and don't apply on the fly transformations, then the features location won't match. So we can see that this is a huge problem. To make sure again, if we remove the layer and try to edit again with transformation, we can see that the location has matched. So we can say that this knowledge is fundamental to work with data from different sources. I hope you learned something new today. Thank you for watching.